Okay, it's called Trig Identities. Okay, so on this sheet, you see a whole bunch of trig identities. Okay, so what I'm going to do is I'm going to do examples from each little section so you can see what's going to happen, and then we'll do an example where you just don't know. Okay, so the first example that I'm going to do is going to be in regards to the reciprocal. Oops. Identities and the quotient identities. Okay, so yeah, reciprocal. Okay, so in the middle, this middle one has your reciprocal identities. So as you guys look at that, I hope that that does not look too new to you. Okay, you should know that sine is equal to 1 over cosecant. They're reciprocals. Okay, and cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. Okay, so then the quotient one, this one is new. That's over on the far left. There's only 2 quotient identities. Okay, the one is that tangent is equal to sine over cosine, and then obviously just kind of the reciprocals of that. Cotangent is cosine over sine. Okay, so this is an example of what you will see. Okay, they'll give you something like the cosecant of the angle is 7/4. So see if you can figure out what the sine is. Okay, so if you know that the cosecant is the reciprocal of what? Sine. All you have to do is say sine is what? 4/7. Very good. Okay, so sine is 4/7. Okay, now that one was pretty easy. So let's do one that's a little bit more complicated. Okay, let's say they give us a cotangent equaling 2 over 5 square roots of 5, which I'm not a huge fan of, but that's the way they play, so we have to play their game. Yeah, but if it's given to us, you just take what's given. Okay, and the sine is a square root of 3 over 5. And let's say they ask us to find the cosine. Oops, cosine of angle. Okay. So if I have a cotangent and a sine, and I'm thinking about cosines, of those 2 identities, the reciprocal and the quotient, how can I make a cotangent play with a sine and a cosine?
Put cosine over sine.
Okay, there you go. Yeah, you got the right idea. So the identity that we're looking at is the quotient one. So cosine or cotangent is cosine over sine, right? You guys see that identity? So then all I'm going to do is I'm going to replace the values with what was given to me. So what was the cotangent value? 2 over 5 square roots of 5. We don't know the cosine, that's what we're looking for. The sine that is given is what? The square root of 5 over 3. I don't think of it as in terms of a triangle and a hypotenuse anymore. Think of it in terms of ratios and fractions. Okay, so all I'm going to do is see the part where I have cosine over that fraction. If I have cosine being divided by something, how can I send it to the other side? Multiply. I'm just going to simply multiply both sides by the square root of 5 over 3. Okay, so that sends it to the other side. Now on the left-hand side, what do you notice? Okay, good. The square roots cancel. And then what do I have left on the top? 2 over 15. Good. Okay, so that is the value of the cosine. Okay, let's do one more. Okay, so let's say they have the cosecant is 25/7, and the secant is 25/24. And they ask us to find the tangent. Okay, how could we do this one? Okay, so we can start with the reciprocal identities, right? So if I have a cosecant, can I go straight to the fact that the cosecant is the reciprocal of sine, and so therefore the sine is what? 7/25. And if I have a secant, then all I have to do is just flip it to find the cosine, right? So what would the cosine be? 24/25. Okay, so now if I'm going to play with tangent, what am I going to use in order to move into sines and cosines? Okay, good. Okay, so according to my quotient identity, tangent is sine over cosine. So all I'm going to do is plug in those values. So sine is 7/25. Can I go to the fact that since I'm dividing by a fraction, that's the same as multiplying by the reciprocal. So the reciprocal of 24/25. 25/24. So what do you notice? 25's cancel, and we have 7/24. What do you guys think there? Not bad? Okay. So let's move into a different identity. Let's talk about the Pythagorean identity. So let's do number 4. So everybody see the Pythagorean identities there? Those are the ones on the top left with, so if you look at all 3 of those identities, what do you really notice about them? They kind of look Pythagorean like theorem, like what specifically is obvious about them? Squares. Okay, so you have functions that are being squared. Okay, so notice that there's also a 1 involved. So there's an adding of 1 somewhere. Okay, so this is going to be one involving Pythagorean. Okay, so they're going to give us a tangent. Let's say it's -8. And they're going to tell you that the sign has to be positive. So let's see if we can find the sign. Whoops, not the cis. I don't know what that is. The sign. Okay, so I told you that we're going to use a Pythagorean identity. Okay, so if you look at the 3 Pythagorean identities, which one involves a tangent? The second one. Okay, so you guys see the second one looks like tangent squared plus 1 is equal to the secant squared. Okay, so all I'm going to do is I'm going to replace the tangents with a -8. Okay, so on that left-hand side, I'm going to say, oh, since it's tangent squared, I should really have -8 squared plus 1. Okay, so now I can simplify this, right? So I have -8 squared, which is 64. And if I add 1, that makes 65. So if I'm going to solve for just the secant, what would the secant be equal to? Is there anything I would need to add to that? You could say over 1, but you don't have to. But if I'm solving an equation and I take a square root, I need a plus or minus. Okay, so keep that in mind. That'll play into fact later. Okay, so now since I know that I have a secant, where am I trying to go? The sine. Okay, can we use a reciprocal identity here and say that if I have a secant, what is my cosine?
Yeah.
So what is the cosine?
Square root of 65.
Ooh, good mental math. Did everybody catch that? Because it would be 1 over the square root of 65, which is the square root of 65 over 65. Technically plus or minus, right? Just can't leave a square root in the bottom. Okay, so now what I'm going to do is I'm going to go back and use a reciprocal identity because right now I have a cosine. Okay, and remember back at the original, I had a tangent involved. So what can I use that has a tangent, a cosine, and a sine all involved?
The quotient.
The quotient identity. Okay, so you guys remember the quotient identity says the tangent is equal to the sine over the cosine. So now I'm just going to fill in my values. The tangent was given to us as -8. The sine is still what we're trying to find. And the cosine is the square root of 65 over 65. And we still are unsure if we want plus or minus there. Okay, so on this step, if I'm solving for sine, what do I have to do to get rid of the square root of 65 over the square root of 65? Good. So I'm going to multiply by the square root of 65 over the 65. I'm just going to go like that. So then the sine is -8 square roots of 65 over 65. Everybody okay with that? Okay, now I do have a plus or minus involved, right? I need to make a decision if this is going to be a positive or a negative. Okay, and I can make that decision based on the information that was given initially. What does it say? Okay, so if the sign is greater than 0, I know it has to be a positive sign. So I'm going to call that quits. Everybody okay on that one?
Is there like a possibility that it's specified?
Which